Okay, we are moving on to section 7, solutions. So we're looking at table G. So how many grams of NH4Cl are required to saturate a 100-gram sample of water at 30 degrees Celsius? So look at table G. Find NH4Cl, 30 degrees Celsius. So NH4Cl, 30 degrees Celsius, and it starts to get crowded, right? Make sure I'm still on that line. Okay. So NH4Cl, you can see right here, NH4Cl, 30 degrees Celsius, right? And I'm going to go across. So what are we at? About 42 grams, because saturated means on the line. Now it says, what is the solubility of KNO3 in 50 grams of water at 60 degrees Celsius? So first, KNO3, right here. And I need what temperature? 60 degrees Celsius. So KNO3, 60 degrees Celsius. So 60 degrees Celsius, go up right here. KNO3. Go across. It's like 106, but 100 grams of water. How much water do I have? 50 grams. So cut this in half, and I get 53 grams. Okay, molarity. What is the molarity? All right, so molarity. Moles of solute over liters of solution. So molarity equals moles over liters. So I have, what is the molarity if it contains 20 grams of this? Okay, so I need to get moles first. So let's go back here. Moles equals mass over GFM. So our mass is 20.0 grams. Our gram formula mass is 40. So that's half a mole, right? 0.50 moles. So our moles is 0.50 moles. Our liters, see this? But this is in milliliters, so I have to change it. So 123.40 liters. Then I just do that simple math. 0.50 divided by 0.40 equals 1.25 molar. That's my answer. How many grams of NaOH are needed to make 500 milliliters of a 2.200 molar? So use the same formula. Molarity equals moles over liters. This time I know my molarity, 0.200 molar equals, well, I can only find moles here first, right? Liters, 0.500 liters. So remember, I got to convert that. So remember, think about this over 1. So to get moles, I'm just going to multiply those two together. So 0.200 times 0.500. Moles is 0.1 mole. But I didn't want mole, I want grams. So I got to use this formula, right? So moles equals grams over gram formula mass. 0.1 moles equals grams over, my gram formula mass is 40.0. And then remember, think about this over 1, so cross multiply. So my grams is going to be simply 40 times 0.1. So 40.0 times 0.1, 4. So 4 grams. All right. Which solution of NaCl has the highest boiling point? Well, you have the highest boiling point when you have the highest concentration. There's the highest concentration. Which has the lowest freezing point? Well, we have the lowest freezing point when it has the most ions or the most particles. Okay? So NaCl separates into one Na and one Cl. CH4 is covalent or molecular, so it stays stuck as one thing. CaCO3 separates into one Ca, but CO3 is a polyatomic ion, so it stays stuck together. And then MgCl2 separates into one Mg and two Cls. So which will have the biggest effect? This one, because it separates into three particles. This is only two particles, one particle, and two particles. So it would have the lowest freezing point, but also the highest boiling point. Because remember, when we add something to water, the freezing point goes down, but the boiling point goes up. All right, that is the end of section 7.